Hi everyone, my name is Giuseppe di Modica. I'm with the Department of Computer Science and Engineering at the University of Bologna. I'm going to present my work titled Design and Implementation of a Platform for the Management of Digital Twins in Industrial Scenarios. This work has been co-authored by myself and some colleagues of mine in the context of the IoTwins project. This is the agenda of my talk. The first part of this talk, I will briefly present the IoTwins project, which is the project that partially supported this work. I will touch on digital twins and their employment in manufacturing environments, and we'll discuss about the IoTwins reference architecture, and I will then conclude my talk. So IoTwins is an H2020 EU-funded project. The main mandate of IoTwins is to explore the benefits of digital twins in particular scenarios like the industrial manufacturing and facility management. The main goal of the IoTwins is to implement a flexible and open platform to allow SME and big enterprises to benefit, to take advantage of distributed and edge-enabled digital twins of production plants and processes. And the second main of this project is to democratize the access to digital tools, also to those enterprises that cannot afford buying very expensive IT infrastructure and tools in the way to their transition to Industry 4.0. Some figures from the project. There are 23 top-level partners from both industry and research, coming from 7 countries based in Italy, Germany, Austria, France, Luxembourg, Spain, and Denmark. And 12 industrial testbeds are going to be deployed that will be used as demonstrator for the outputs of the project. In this picture, I have depicted some of the words that characterize the project. In the foreground, you may notice the fourth industrial revolution, but also other interesting technologies and groundbreaking technology, I would say, like digital twins, artificial intelligence, big data, cloud, edge, machine learning, and so on. Let me give a very quick and synthetic definition of digital twins. A digital twin is a digital software model that, if adequately fed with data, can represent a physical entity, which is called physical twin, along with its performance. So we're going to use digital twins as software models of physical entities in order to control physical entities by way of software models. I can just provide you with a few examples in the context that we are focusing on the IoTwins project. We can build a digital twin out of a manufacturing infrastructure or out of a production line, or we can build a software digital model of a machine or even a machine part. And this is done in order to control the process, the behavior of physical entities. Being software entities, twins can be executed anywhere. Anywhere there is some computing infrastructure that is able to host a digital twin. So we can build digital twins at IoT layer, specifically for filtering data or cleansing data. And this is because, of course, of the low computing capacity that our devices are provided with at this layer. In the edge layer, which is where much emphasis is put in the IoTwins project, of course, there's much capacity that we can exploit. So edge is also close to things. And of course, we can build specific digital twins for real time. So delay sensitive tasks like, for instance, machines closed loop control with a very low round trip time. And finally, digital twins can be built at cloud layers as well, where there is a very high computing capacity, but resources are far from things. So they are good for data intensive tasks, but we are not able to run, of course, real time or time sensitive tasks. In the framework of IoTwins, we have we are building up twins for the three computing layers. On the left side, you may see the infrastructure monitored by sensors. So data are streamed to the IoTwins layer, where they can be, of course, sort of pre-processed with very quickly, and then pre-processed data can be transferred to edge twin, which is where some kind of other tasks can be carried out like optimal locality control, but other data management tasks can be run here as well. And finally, data are transferred to the cloud, which hosts very, I would say, computing intensive applications like physical simulation or machine learning training, machine learning models training. And this is where machine learning models are trained and are then moved back to edge, where they will act as process control for the data coming from the IoT. This is a very short list of applications and services being developed in the context of IoTwins. AI-based service, mostly. So machine or deep learning models being developed for anomaly detection or uh, to build models for anomaly prediction, but also simulation models are for machine simulation, for instance, and also optimization models to do some kind of workload management or to schedule maintenance shifts. The main purpose of IoTwins is to build an open architecture with open interfaces in a way that allow users or developers, not just the ones that are involved in the partners involved in the IoTwins project, but also third parties to develop services according to the IoTwins paradigm. Um, of course, manufacturing is the main sector that being addressed in the context of the IoTwins, but other sectors may benefit of the IoTwins paradigm as well, like for instance, smart cities, smart agriculture, smart buildings, and so on. There's further research going on to study how federated learning can be run. By using massively edge computing resources, or also how to develop service level agreements on quality requirements for resources that are natively spanned on a cloud continuum. In the first part of the iTunes project, we ran some kind of elicitation of requirements. So functional and non-functional requirements have been gathered from the partners through questionnaires. It turns out that testbeds are going to be very heterogeneous from different perspectives. For instance, some of them adopt proprietary solutions. Others do not possess the skills to face this industrial revolution. For some partners, edge is still under observation. They're willing to move towards the edge, but they don't know how to do that. So this heterogeneity is not a threat to the project. Of course, it's a good opportunity indeed, because it provides very rich and challenging requirements, and we will be able to build a perfect test bench for the outputs of the project. Um, In this picture, I have depicted use cases that have been elaborated after requirements being elicited. Basically, the IoTwins users will be benefiting of functions provided by the platforms. So you will be able to configure, deploy, and run services in the cloud continuum. So it will be able also to provide pipelines of services that spans the whole chain of computation. And this is the reference architecture. This is basically composed of 4 layers. And the first layer, application will be developed. Typical application would be data analysis, model, machine learning, training, or running model. Provide the right runtime environment for machine learning models. Underneath, the platform service layer will provide services for data communication, data storage, or service monitoring. And it is where a service repository will be set up, of course. So this is where IoTwins user will look up when they need some specific service. A specific component will be developed to orchestrate services. It will be used by the IoTwin users to orchestrate, to make the deployments and to control the deployments and the environment and the behavior of their services on the run. The resource management layer is responsible for schedule resources, configure resources. There is going to be some registry for computing resources. And when I speak of resources, I mean computing resources which are underneath in the form of bare metal, for instance, or containerized resources, or again, virtual machine resources. 2 more components are envisaged that will manage identity and data encryption respectively. This is an example of services that could be deployed in the cloud by means of functionalities provided by the application. So typically in the cloud, the user will be able to set up a messaging system to receive streams from the edge, and then, of course, to implement their applications like simulation or optimization, training machine learning models, etc. As for the edge, a data collectors component could be set up that speaks with the IoT on the one end by means of adapters, on the other one implements messaging systems to transfer, to stream data up to the cloud. And here, of course, some kind of computation can be run as well to enrich data or to filter or to cleanse data, all that is needed for data processing purposes. On the IoT level, it will be possible to install, to develop, to deploy some kind of services to receive data from sensors, to communicate those data to the edge, and if the hardware is capable of supporting this kind of operation, it will be possible also to pre-process data. Platform prototype of the architecture is being implemented or is under development. It is based on the Indigo Pass orchestrator. It's an open source software provided by the INFN partner. Some technologies, some open technologies specification are involved in the implementation of the platform prototype. You may see here Oasis Tosca standard, OpenStack, Docker, CE, Community Edition, Apache Mesos, and so on. And a roadmap for the integration of all testbeds being laid down. So to conclude, in this talk, I have presented the reference architecture of an open platform that will enable SME and big enterprises to design and implement edge-based digital twins of production plants and processes. We strongly believe that this platform will democratize the access to digital tools in the path to Industry 4.0. For the future, of course, we are going to enhance the prototype with new features. And we will enforce the integration of all testbeds with the platform. And one of the goals of the project is to define business models and business cases that will allow an exploitation of the IoTwins paradigms also at commercial level. That's it. Thank you for your attention. If you have any questions, please drop me an email.